Today's topic is the types of agents in artificial intelligence. So, types of agents, AI agents. AI agents is doing the specifically works are the foundation of many intelligent systems, which helps them to understand their environment, make decision, and act to achieve specific goals, ranging from simple rule-based to adaptive learning models. So operate autonomously. Agentic AI operates autonomously with minimal human intervention, directly giving the automatic answers or outputs. Used in application like assistant, you will use like Siri, Alexa, or it's a AI agent. So and like assistants, automation, and robotics is the using the AI agents in automation in robotics. So in types of agents, multiple many agents, like many types of agents. So first agents is a simple reflex agent. So it's give the condition action rules only, and what is the world you like sensors use, what the world is like now, what actions I should do now, and actuators actuators and its user percepts and actions using the actions environment giving the output. It's a simple reflex agent, not high level agents like you will use give the chat something hi or hello. It's using that. So simple reflexes act only on the current input using predefined roles without memory or history. It's not using the memory or history or predefined rules. They are fast and suitable for simple. It's using the almost fast because of not history included, not memory included, not using the not thinking like large language model. So it's so fast and it's so simple and fully observable environments but perform poorly in dynamic like you will use only chatbot hi hello वगैरह. It's perfectly used but not using the sending the any message, sending the any videos or recognize any videos. It's not work together. So dynamic or partially observable situation due to lack of memory and reasoning. Reactive, these agents respond immediately to inputs without consideration for prior events or predicting future outcomes. And limited scope, they excel in predictable environments where it's a limited scope task and straightforward and the relationship between actions and results are well understood. Quick response, since the decision are made based on only on immediate input, it can react without delay. No learning, these agents cannot improve or change their behavior based on past experience. So example is traffic light control system that changes a signal based on fixed timing. It's using the simple reflex agent, traffic light control. So another agent is a model based reflex agents. Using the model, you will use the LLM, large language model, and giving the output. So state how the world evolves, why my actions do. It's using the model based. It's a model based reflex agents. So describely model based reflex agents improve simple reflex agent by maintaining an internal state of the environment to handle partially observable and changing situation. However, their decisions are still mainly reactive and depend on the accuracy of the internal model. So internal state maintains an internal model to handle partially observable environments and support flexible decisions. And also adaptive updates its internal state based on new information to adjust to changes. For a better decision making, user stored information to make more informed and reliable choices. And in the model based reflex, we will use the increased complexity. In model based use the increase in complexity because of using the model. LLM, large language model, requires more memory or RAM or storage and computation to maintain and update the internal model because of is the model of increase the complexity. Example, robot vacuum cleaner. You will use a robot vacuum cleaner that maps rooms and tracks cleaned areas. It's a simple example of model based reflex agent. So another is a goal based reflex goal based agent. So goal based agents working directly only one goal. So you will send in the Gmail, so you will send only Gmail, not another work, or not another sending the message, not another call any person. So only work doing the goal based agents. So goal based agents work likely you will using the states, how the world evolves, what may actions do, goals, and using the senses what the world is likely now, what is the world like, and what action should you do. It's using the sending the environment input or output. It's artificial intelligence. So goal-based agents choose the action by evaluating future states in relation to defined goals. They can plan action sequences to achieve objectives, enable more flexible problem solving, but depend on clear goals and effective planning methods in complex environments. So is the goal-oriented, makes a decision based on how well actions align with defined objectives. Planning and search use a planning algorithm to evaluate possible action sequence to reach goals. Flexible replans and adjust the strategy when conditions or information changes. Future oriented, unlike reflex agents, they think ahead and predict future outcomes to find the best course of actions. An example is the logistic routing agents that find optimal delivery routes or based on factors like distance and time. So they continuously adjust to reach most efficient route. So utility based agents, it's a utility based agents work like environment. All utility based processes get current state, generative possible actions, predict outcomes, evaluate utility, choose best actions, execute actions. So likely it's utility based actions using the confusion matrix, true false, true negatives, false negative, false. So is the utility based agents working the more utilities in one agents. So utility based agents to go beyond goal based agents by evaluating how desirable different outcomes are using the utility functions. This allows them to make trade offs and choose the most optimal action in uncertain or limited resources situation. So their performance depends heavily on how well the utility functions is designed. So multi-criterion decision making utility model. So it consider multiple factors such as the cost, benefits, risk, and time to choose the best action using the multiple components, like using the you will use factors cost, benefit, risk, and time. You will classification, regression, training the LLM model on these factors and give the best action. And it's a multi-criteria decision making trade-offs. So make decision by balancing competing goals and performance, often finding the best compromise. So subjectivity adapts to user or organizational preferences through customizable utility functions. And increased complexity, finding the utility functions for different factors can be computationally intensive and complex. So example is a financial portfolio management agent that evaluate investment based on factors like risk, return, and with diversification operates by choosing options that provide the most value. Learning agents. So learning agents is the learning the like using the LLM, learning the more factors, more components, and you these factors using the like if we will use the history memory, using the you will use a factor database, you use the large language model, you will use a olama mistral 7 billion instruct. So all this performance in the one agents. So perform standard, critique, sensors, feedback, learning element, changes and knowledge, changes using the back propagation, forward propagation, performance elements, learning goals, problem generator, experiments, efforts is the sending the input and giving the output to environment. So learning agent improves performance over time by learning from experience and updating their models or strategies. They adapt to changing environments and typically use supervised, unsupervised, or reinforcement learning. Supervised means using the label, give the output, and unsupervised using the non-label data or give the clusterings. Or in reinforcement learning, we will use like in a chess game to playing the another side robot. And in the learning agent, we will explain that adaptive learning improves their decision making through continuous feedback from their actions, explorations versus exploitation, tries balancing new actions and using known successful strategies. Flexibility, adapt to wide variety or of task or environment by modifying their behavior based on new data. Generalization, applies lessons learned in one context to new similar situations, enhancing their versatility. So example is customer service chatbots can improve responses accuracy over time by learning from previous interaction and adapting to user needs. So multi-agent system. Multi-agent systems work some more agents in one agentic AI. So like you will use a YouTube agent, WhatsApp agent, Gmail agent, project agent, like Jarvis. It's you will know about a Marvel Iron Man, and you will know about a Jarvis. So in multi-agent, single agent, multiples using the use the single agents network. You will create the main or connecting to the another agents too, like you will WhatsApp agent or task agent, YouTube agent, or so Gmail agents. So including the task, sending the dose time of the any message to another person or another Gmail to company. Supervisor, like you will create a one agents and handling the another agents. It's like a supervisor. Supervisor as tools like LLM using the supervisor tools, like sending the any using the tools model context protocol, like sending the WhatsApp agent system or Gmail agent system or voice recognition system. Means the supervisor handles the as tools. Hierarchical means using the you are the studying in machine learning, unsupervised learning, hierarchical clustering. So multiple agents clusters the one agents handle the another one agent, hands another agents to handle the one agent, and those two agents working one agents. You will like you know about key Alexa. So Alexa sending the use the call agent for calling, for YouTube agent for playing songs, for Spotify playing songs, or any sending the message WhatsApp. It's WhatsApp agents, like you will a Gmail agent, WhatsApp agents, or playing songs. It's a monitor tools. It's a monitor agent, and these agents to monitor by our supervisor. It's another agents. So and custom agents means sending the data to another agents and taking the data to another agents, like task based agent system. So multi-agent system involve multiple agents interacting in a shared environment to achieve individual or collective goals. They may cooperate or compete and use communication and coordination to operate, but can be complex due to unpredictable behavior. Types of multi-agent system. Cooperative mass. Agents work together towards shared objectives. Competitive mass. Agents pursue individual goals that may conflict. Mixed mass. Agents cooperate in some scenarios like and compete and others. Key characteristics of agentic AIs. Agentic multi-agentic AI. Autonomous agents. Each agent acts its own based on its goal and knowledge. Interaction agents communicate, cooperate, or compete to achieve individual or shared objectives. Distributed problem solving. Agentic AI works to solve the complex problems. Decentralization, no center control. Agents make decision independently using the LLM, large language model. A warehouse robot use AI methods like reflexible for navigation, planning for task, utility based choices for prioritization, and learning for route optimization. So another is the hierarchical agents. It's more than it's a 7 or 8 agents. So there are seven main types of agents. So 1 minute. Okay, the main types of agents explained. So in the hierarchical agents, use a multi-agent systems. In the So firstly, in hierarchical agents, so the 7 agents. So is the first is the simple reflex agents. Another is the model based agents, goal based agents, or utility based agents, or learning agents, and multi agent systems, and hierarchical agents. Hierarchical agents means one agent is supervisor, another agent is doing the another work in the that agents in downside another agents are work. So like Jarvis work agent, one agent to another agent to sending the data, third agent, fourth agent, fifth agent. So working like hierarchical structure. So hierarchical agent structure behavior into layers. such as strategic, tactical, and operational. Higher levels set goals that are broken into smaller tasks for lower levels, improving scalability and handling of complex tasks, but requiring well designed coordination between layers. Structured decision making. Decision making is divided into different levels for more efficient task handling. Task division. Complex tasks are broken down into simpler subtasks. Control and guidance. Higher level direct lower levels for coordinate actions. Comparison of AI agents types. So comparison of AI agent types. So main strength is a simple. I will explain the main strength limitation based for our example. So see, in a simple reflex agents, instant reaction based on fixed rules. Main strength is, and limitations is no memory or learning fails in dynamic environments, and best for fully observable, stable, and simple environments. Example is a traffic light. Model based reflection and main strength is a handles partial observability with internal state. Uh, Limitations more competition, demand depends on the model accuracy, dynamic or partially observable environments for best. And example is robot vacuum cleaner. Goal based agents, it's a plans ahead to achieve specific objectives is the main strength, and limitations is the needs clear goals and planning algorithms, and best for strategic tasks with the defined goals. An example is a logistic routing, route planning. Utility based agents, main strength is a balance multiple factors for best outcomes. Limitations is requires complex utility functions, and best for multi criteria decision making. An example is a financial portfolio management. A learning agent is the main strength is improves over time via experience, and limitations is need some data and training time, and best for dynamic environments with changing conditions. An example is AI chatbot like ChatGPT, Claude, DeepSeek, AI, Gemini, something else. Multi-agent system, main strength is a distributed problem solving with cooperations, and limitations is complex interactions, and best for decentralized multi-entity systems. An example is smart traffic control or agentic AI. It's like WhatsApp agent, Gmail agent, or Jarvis, or like that. Or competition unpredictable behavior. Okay, forget it. Hierarchical agents, where limitations is requires well defined interfaces between layers, or strength is breaks complex tasks into levels for efficiency, or best for large scale multiple level operations. An example is a drone delivery management. And when to use each AI agents, so why use agents, like we will use the environment is fully observable and predictable, tasks are repetitive with fixed rules, we will use the simple reflex agents. Another second agent is a model based reflex agent, some information about the environment hidden but can be modeled, environment changes but follows predictability patterns. And third is a goal based agent, task requires planning multiple steps ahead, clear goals are defined and can be measured. Okay, utility based agent need to balance trade off like cost, time, and risk, multiple objectives must be prioritized. Learning agents, environment changes over time and the system must adapt, performance should improve with experience. Multi-agent system, multiple agents must work together or compete. Problem solving is decentralized and distributed. Hierarchical agents is the task can be split into strategic, tactical, and operational levels. Large scale operations require coordination between layers. Okay, thank you. These are the main agents in agentic AI. Another part of videos we will learn the another concepts. Okay, thank you. Keep learning, keep growing.